Last 10 seconds remaining. Okay, so most of you have answered the correct answer for this question. The option A is the correct option. The pH range for acids starts from 0 up to less than 7. Then for bases, it starts from above 7 up to 14. And for neutral, the pH value is 7. So now we will go for the principle or the working of pH measurement. So as you can see, it consists of one reference electrode and one sensing electrode. So every pH measurement system consists of these two electrodes. First one is the reference electrode and second one is the measurement or sensing electrode. The most common pH measurement system consists of glass pH electrode. The system consists of a pH sensor, a reference electrode, a conductive electrolyte solution, which will help to carry the uh, potential from the sample solution to the pH measurement system, and a meter which will convert the potential signal to the pH value. The meter measures the voltage difference between pH half cell and reference cell. Here half cell means the sensing electrode or the measurement electrode, and then it is converted into pH units by using the Nernst equation. So Nernst equation is the basic equation which is used in the electrochemistry for the conversion of millivolt signal into the pH value. So by using that equation, we measure the potential difference between the reference cell and reference electrode and measure sensing electrode, which is then converted into the pH value. So now we will see the difference between half cell electrodes and combination pH electrodes. So in the initial period of time, we had to use the two different types of electrodes, just like shown in the previous figure, this one. So the principle consists of one reference electrode and one sensing electrode. So in the initial period of time, we had to use the two different types of electrode for pH measurement. But now currently we are using the combination pH electrode, which is more common and which is more convenient to use. So in combination pH electrode, uh, the reference electrode as well as the sensing electrode is consistent single electrode only. So here we can see initially it was necessary to use a glass pH sensor and reference electrode separately. pH sensor was used to sense the activity of hydrogen ions, so that it is called as sensing electrode, while the reference electrode was used to provide a stable reference voltage for the sensing electrode. So now it is more common to use the combination pH electrode, which has both sensing and reference electrode inside a single body. So in case of combination pH electrode, we don't have to use two separate electrodes like reference electrode and sensing electrode for pH measurement. We can carry out our analysis by using single combination electrode only. So now we will go for the classification of pH electrodes. So the points on which the pH electrodes are getting classified are as follows. Depending upon the reference junction in the pH electrode, then the number of ceramic junctions present in the pH electrode, then types of ceramic types of junctions, then glass type which is used for the preparation of that pH electrode, then the shape of sensing membrane or the sensing tip, then the types of connectors which are available to connect to your pH meter. So along with these, there are some additional points also. These are some basic points which will be make impact for the selection of pH electrode. Okay, so we will see uh, one by one type and what is the difference between those particular classifications. So first point is reference junctions. So pH electrodes are basically classified into single reference junction electrode and double reference junction electrode. So what is the difference in between these two electrodes? We'll see. So in single junction electrode, they have only single junction which serves to put the reference electrode system in contact with samples. So in case of below image, you can see in case of single junction electrodes that AgCl reference wire which works as a reference electrode comes in directly contact with your sample solution through the ceramic junction. So there is no any extra protection or extra jacket present in the single junction electrode. The contact between your reference electrode and sample is directly through the ceramic junction. Under adverse conditions of pressure, temperature, acidity or alkalinity, the flow of electrolyte solution can get reversed, which leads to the contamination of electrolyte solution and complete electrode failure. So basically, when we are using the pH electrode, the electrolyte solution which is filled inside the pH electrolyte solution which is filled inside the pH electrode flows from inside to the outside. This is the normal process. But in case of adverse conditions, this flow can get reversed. So in that case, if your sample solution is getting into your pH electrode, then it can contaminate your electrolyte solution, which will lead to the electrode failure. So this is the drawback of single reference junction electrodes. Also, single junction can get clogged due to the precipitation of AgCl solution, silver chloride solution. So in the reference electrode, AgCl solution is there, and if we are dipping the single junction electrode directly into the sample, then there are chances of clogging at the ceramic junction due to the precipitation of AgCl with the sample solution. So this is the case in the single junction electrodes. So we have seen the concept of single junction as well as the drawbacks of single junction. So now we will see the double junction pH electrodes. So the double junction pH electrodes have two junctions, only one of which is directly in contact with sample solution. As the reference electrode system is separated physically from the intermediate electrolyte area, the contamination of electrolyte is minimized. So in the double junction electrode, you can see in the image, the reference electrode is protected from the direct contact with sample. So there is extra jacket is present named as inner ceramic junction. So in this case, there are two junctions present due to which the direct contact of your sample to your electrolyte solution is avoided. So even in adverse conditions of acid and bases or any pressure and temperature conditions, the reverse flow of sample into the electrolyte solution is avoided. Also, the outer reference cell uses the fill solution that is silver free, so no precipitate can form to clog the junction. In case of single junction electrode, we have seen that the AgCl solution is used as electrolyte for the reference electrode. But in case of double junction electrode, the reference electrode is protected from the outer ceramic junction. So there is no direct contact between silver and the outer sample, which will lead to no precipitation can be formed due to the direct contact of sample to the inner electrolyte solution is avoided. So on this basis, you can select your pH electrode by checking the junctions present in your pH electrode. So as per your convenience and application suitability, you can select the pH electrode. After these reference junctions, there is another point which will affect the analysis or which will affect the accuracy of your sample solutions. So number of ceramic junctions. So what is ceramic junction basically? Ceramic junction is a porous part of pH electrode through which the inner electrolyte solution flows in the sample solution. Depending on the number of these ceramic junctions present in the electrode, the rate of flow of electrolyte solution is fixed. So now we will see the classification on basis of number of ceramic junctions. So we have the options of single ceramic junction, double ceramic junction, triple ceramic junction, and open junction electrodes. So basically, in case of single ceramic junctions, they have only one outlet for the electrolyte solution. So as it has only one outlet, the electrolyte flow rate is less in case of single ceramic junction electrode. In double ceramic junction electrode, the rate of flow of electrolyte solution is increased from 15 to 20 microliter per hour to 30 to 40 microliter per hour. So even in the case of triple ceramic junction, we can see the flow rate is quite higher than that of the double and single ceramic junction electrode. So, in case of triple ceramic junction, as the electrolyte flow rate is higher than that of the remaining electrodes, the pH values can get stable more easily and in lesser time than that of the double and single ceramic junction. The stability of your pH readings and accuracy of your pH readings depends upon the flow of electrolyte solution in your sample. So if you have any more acidic or more basic samples, or if your sample has lower conductivity values, then in those cases you can go for the triple ceramic junctions, which will be ideal for your application. Then there is open junction electrodes. In open junction electrodes, uh, there is no any uh, filter present for the electrolyte flow. The sample directly comes in contact with the gel electrolyte, which is filled in the pH electrode. So this will give the more reliable and which will be more applicable in the semi-solid samples such as food samples or high viscosity samples, which are the lower conductivity. So in this case, I'll just put another poll for you. So you will have the 30 seconds to answer this question. Which of the following solution is commonly used as electrolyte solution for pH electrodes? So your first option is HCl solution. Your second option is KCl solution, potassium chloride and hydrochloric acid. Last 10 seconds are remaining. Okay. So the correct answer for this question is the KCl solution. Generally, in most of the pH electrodes, glass pH electrodes, the 3 to 3.5 molar KCl solution, which is considered as the saturated KCl solution, is used as an electrolyte solution. Only KCl solution is used in case of aqueous samples because KCl has the higher dissociation constant. So we use potassium chloride solution as electrolyte solution. In non-aqueous samples, we can use the saturated lithium chloride solution in either propanol or ethanol. So now we will see the selection of pH electrode based upon the types of junctions present. So there are different types of junctions are present. In previous slide, we have seen the differences between the ceramic junctions, the number of ceramic junctions. Now we will see the generalized types of junctions which are present in the pH electrode and uh, for which applications they are used. So the first type is porous ceramic junction. So porous ceramic junction is normally used in the electrodes with the glass bodies. Ceramic is available in different porosities and diameters. This type of electrodes is used for the general laboratory purposes. So the ceramic junction is the first type of junction. Uh, Generally comes with the glass body pH electrodes and which is generally used in the normal or general laboratory applications. We have again seen the classification between the ceramic junctions in the previous slide. So the second type is porous PTFE junction. You can see the image given below. So the first one is the ceramic junction. The second image is for the porous PTFE junction. So the porous PTFE is hydrophobic material that is available with different porosities. Because of its chemical resistance, PTFE is used widely in industrial applications. So as you can see, it is a hydrophobic material. So it is more suitable for the industrial applications. It also comes with the different porosities and different sizes. So by using this electrode, you can analyze your industrial samples. Then there is a fiber wick junction. This type of junction is often used on plastic body electrodes with gel electrolytes. So in case of plastic body electrodes which are non-refillable, so some electrodes are refillable and some are non-refillable. In refillable electrodes, you can fill the electrolyte solution such as potassium chloride or lithium chloride through the electrolyte solution filling hole. After decreasing the level of that electrolyte solution, you can again refill it. But in case of non-refillable electrodes, gel electrolyte gel is used as an uh, electrolyte. So in that case, for non-refillable electrodes, the fiber wick junction is used, which is generally used for the plastic bodied electrodes. Then there is open junction electrodes. Open junction electrodes are filled with a special gel electrolyte. This is again non-refillable one, which comes into direct contact with the sample solution. Open junction pH electrodes have low contact resistance and low clogging potential. So these types of pH electrodes are generally used in food industry or some viscous samples or semi-solid samples. Then another type of junction is the cone style junction, uh, skirted cone type junction. So these types of electrode have the higher flow rate than the ceramic junction. So the flow of electrolyte solution into your sample solution will be higher in this case. So it is mostly used in the case of ion selective electrode measurements where the higher electrolyte solution flow is required. So we have seen the types of junctions present in the pH electrodes. So according to your application, you can go for the particular type of junction. So the next classification for the pH electrode is glass type used for the preparation of that pH electrodes. So the characteristics of sensitive glass used in the manufacturing of pH electrodes are extremely important in determining how the electrode will respond. So depending on the glass type, the nature and the response of the electrode will also be determined. So characteristics of glass include workability, impedance of glass, then the pH range, hydrofluoric acid resistance, and abrasion resistance. So depending on these points, the pH electrodes are classified. So HANA utilizes 4 different types of pH sensitive glasses to cover the vast number of applications. So we will see which options are available for the glass type. The first one is the general purpose or GP glass. So HANA's general purpose or GP glass is hydrogen sensitive glass, which provides the best response over the entire pH range and can be used for a wide range of applications. So this is general purpose glass. So the range for the pH measurement is wide, starting from lower pH ranges up to higher pH ranges. So it covers the wide range of applications, and it is used for general laboratory purposes. Then there is low temperature glass or LT glass. These electrodes have the low impedance. So due to low impedance, low temperature glass is used on a flat and conical shaped membranes, as well as sensors used at cold temperature. So as it is a low temperature glass, some cold samples or lower temperature samples, you can use these types of electrodes. But this glass has a more limited pH range. As we have seen in the general purpose glass, it has a wide range of applications and wide pH range. But in case of low temperature glass, due to the low impedance of that glass, the pH range is limited for the LT glass. Then the next type is high temperature glass or HT glass. So it is designed for extended use at elevated temperatures. So if you have some higher temperature samples, then you can go for the HT glass made pH electrodes. At extremely high temperatures, the impedance drops significantly, and high temperature glass makes it possible to obtain accurate pH readings even at high temperature for extended period of time. So if your sample has the higher temperature for continuous time, then HT glass will be ideal for those applications, because if you are using the HT glass pH electrode, the life of that electrode will be almost 10 times higher than that of the general purpose glass electrodes, because they are specifically prepared for the high temperature samples. Then the next type is HF glass or the hydrofluoric acid resistant glass. So hydrofluoric acid can dissolve the glass rapidly. It etches the glass. So HANA uses the HF resistant glass for the aggressive applications that have fluoride ions. So if your application involves the presence of hydrofluoric acid or fluoride ions, then it will be better to use the HF resistant glass, because if you are using the normal glass pH electrode, then those pH electrodes can get uh, dissolved, or some type of corrosion will be there due to presence of that hydrofluoric acid. The recommended pH range for this glass electrode is starts from 2 pH up to 10 pH, and the samples weigh 2 gram per liter fluoride. So if you have the higher concentration of hydrofluoric acid, then you can use the dilution for the analysis of your sample. So the next classification for the pH electrodes is uh, based upon the shape of sensing membranes. So there are different types of pH membranes, or the tip shapes are available for the different types of pH electrodes. So depending upon your application and convenience, you can select one of those to get the more accuracy and consistent results. So pH electrodes can be fabricated with different shape membranes depending upon the application and the sample nature. The use of correct shape pH electrode is recommended for the better results. So there are generally three types which are commonly used. First one is the most common, spherical tip electrodes. So the spherical tip is recommended for the general use in aqueous or liquid solutions. As the tip is spherical, it provides the wide surface of contact with the sample. So for the general purpose or general laboratory analysis, you can go for the spherical tip. The second type is conical tip. Conical tip is recommended for the semi-solid products, emulsions, cheese, meat, and food samples. So that conical shape is specifically provided for the piercing of sample. So the samples which are slightly more viscous or semi-solid or in the emulsion form, you can go for the conical tip. For most of the pH electrodes used in the food industry, the pH electrodes have the conical shape tip. Then the flat tip electrodes. So in the flat tip electrodes, membrane is at the bottom surface of that electrode. So flat tip is recommended for the direct surface measurement, for the measurement of pH on skin, leather, paper, etc. So if you have such samples or such analysis to carry out, then you can go for the flat tip pH electrodes. So the next classification for the pH electrodes is for based on the types of connectors available. So you can see there are different types of pH electrodes available with the different types of connectors for the connection with the pH meter. So depending on those connectors, you can select your particular pH electrode which will be suitable for your pH meter. So BNC is generally the universal connector which can be connected for the most of the pH meters. So the BNC connector is the most versatile connector as it can be used with any meter that has the BNC connection regardless of the brand. Along with BNC, following are the other connection types available for the pH electrode. So there are 6 to 7 types of different connections available for the pH electrodes. Depending on your pH meter connection, you can select the appropriate connection type and the pH electrode for the analysis. There is PNC type, quick connect diion type, mostly used in portable meters. Then diion connector, BNC plus pin option is also available, banana pin plus BNC connection. Then P type, Y type BNC plus RCA, screw type connectors, and 3.5 mm headphone jack pin is also available for the connection with the pH meters. Along with these mentioned classifications, there are some additional points are also present which will be considered at the time of selection of your pH electrode. So basically, those involve the make of that pH electrode, the body of the pH electrode. So there are different types of body materials available. For example, glass body is the generally used pH electrodes, but along with glass body, PEI body or the plastic body is also available for the food applications. Then some electrodes are with stainless steel body or titanium body for the rough applications. So these things can also be considered at the time of selection of your pH electrode. So here is the list of the application specific pH meters which are provided by HANA. So here you can see the different types of pH electrodes and pH meters can be used for the different types of industries based upon your samples and your applications. The suitable pH meter will be suggested. So we have the pH meter for the food industry, which covers almost all of the food applications. Then specifically for particular industries, we have the milk pH meter for dairies, then meat pH meter. So in meat pH meter will come with the conical shaped pH electrode, which also compatible for the steel blade for the insertion in the meat samples. Then yogurt pH meter, cheese pH meter, uh, beer pH meter for the breweries, wine pH meter for wineries, soil pH meter. You can directly measure the pH value of your soil samples by inserting your pH electrode directly into the soil. So with this meter, a tool is provided for the convenience of convenience to use this pH meter for the soil samples. Then plating bath pH meter. So in electroplating industry, some pH meters are specifically designed for the electroplating industry, which will give the better results than that of the normal pH meters. Then for leather and paper pH meter, skin and scalp pH meter. So in these cases, the flat tip electrode is provided with the meter, which will be helpful for the pH measurement at surface. Then there is a pH meter for biological samples. So In biological samples, the sample quantity is so less, uh, so that it should be taken in the test tubes or the glass tubes. So in those cases, HANA provides a solution for the measurement of pH in the lower sample quantities. So for that, we provide the narrow tip pH electrodes with the pH meter, which is more convenient to use for the lower sample volumes. Then the pH meter for cosmetics industries. So specifically designed pH meter for cosmetic industries, cosmetic creams is also available for the pH analysis. So these are the available types. So you can go for particular application and particular pH meter, which will be helpful, which will be more convenient for your sample application for pH measurement. Along with this, if you have any extra specific needs, you can go for the technical specifications of the pH electrodes, which will help you to select the correct pH electrode as per your application. So along with these meters, one pH tester range is also available from HANA. HANA Hello 2 pH meters. So this is basically a Bluetooth Bluetooth facility pH testers. So they are the handheld testers for the pH measurement. So you will get the complete range for the food samples, then some field applications, some agricultural applications, and the general laboratory applications. So you can check the pH value directly on the meter display, as well as you can use your phone or your tablet as your pH meter. So you can perform your calibration and all of the GLP data by using the your smartphone or your tablet. So this range also comes with the calibration facility, the GLP facility, Bluetooth connectivity. This is more applicable for the portable purposes, portable samples. So here is the summary of today's webinar. So we have seen what is the general concept of pH, working of pH, then the classification of the pH meters and pH electrodes depends upon various factors, then how to choose the correct pH electrode for your corresponding application. Then we have seen the options provided by HANA for the particular pH measurement in particular application. So these are the important points which should be considered while selecting the pH electrode. So the first one is the application suitability. So while selecting the correct pH electrode, you have to confirm the workability of that pH electrode and pH meter for your application. Then the technical specifications of the electrode. So if you need some high temperature pH measurement or some calibration data or some additional technical features, then you can check for the complete technical details of that particular pH meter and pH electrode, and then you can go for that pH electrode. Then the sample nature. Sample nature also plays the important role while selecting the pH meter for your application. So the aqueous, non-aqueous nature, or highly acidic or highly basic nature, or semi-solid or liquid nature. So these types of options are available for your sample. Then depending upon your sample nature, you can go for the appropriate pH meter which will be suitable for your application. Then convenient handling and usage. Along with the technical parameters, you have to confirm the convenience of the pH meter and pH electrode for your analysis. So while handling the pH meter, so these are the important points for the selecting the pH meter. So after selecting, you will have to take care and you have to properly maintain the pH meter and pH electrode as per the given instructions. So sometimes even if the electrode is suitable for your sample, due to the improper maintenance or improper storage, that can be get defective for your application. So you just have to confirm that you are properly maintaining the electrode and you are properly storing the pH electrodes as per the mentioned storage procedure and maintenance procedure. So on this point, I will just raise the another pool. The maintenance. We have the 30 seconds to answer this question, which is more important in case of maintenance of that pH electrodes. State true or false. When not in use, the pH electrodes can be stored in distilled water. So you just have to state the statement is true or false. If we are not using the pH electrode, is it okay to store that pH electrode in distilled water or not? Okay, last 10 seconds. Okay, so I will first publish the result. Almost all of you have given the correct answer, which is this statement is false. We should not store our pH electrode in distilled water when not in use, because the distilled water causes the ions leach from the glass membrane and a reference electrolyte. So that will lead to the slow and sluggish response for your pH electrodes. So when not in use, you always have to store the pH electrode in the storage solution only. Don't use the distilled water solution for the storage purposes. So on this note, thank you all of you for attending the webinar and getting involved in the process of selecting the proper pH electrode depending upon your application. So here is the mail IDs and contact numbers. If you have any further queries, now you can put your questions in Q&A chat box so we can answer. Okay, the first question is from Mr. Sham Kumar sir. So thank you, Sham Kumar sir, for the question. The question is how can calibrate the electrode? So for the calibration, we can use the standard buffer solutions for the calibration. So these are available. These solutions are available starting from 1.68 pH up to 12.45 pH. So there is a standard mentioned procedure for the calibration of pH electrodes, which involves you have to properly clean the pH electrode and use the standard uncontaminated buffer solutions, which should be fresh. So by using those solutions, you can perform the calibration in either 3 point or 5 point as per your specifications. Uh, then there is another question from Bhattacharya sir. So thank you for raising the question. Can you please discuss some info about calibration procedure? Can the same buffers used for all different types of pH meters? So yes, you can use the same buffer solution for different types of pH meter. First solution is basically the uh, solution which has the fixed pH value, which will not get changed for different types of pH meters. But you have to take care that while changing the buffer solution from one buffer to another buffer, that buffer solution should not get contaminated due to water or any different type of buffer solution. So for example, if you are calibrating your buffer, your meter with buffer 4, 7, and 10, you will perform the calibration for 7 first. Then you will have to wash the electrode completely, wipe out the excess water, and then dip the electrode in the next buffer solution. So following this way, the buffers cannot get contaminated. You can use that buffer for the other metals also, but uh, there is possibility that it can get contaminated or the value can get changed due to the repeated use. So by checking the millivolt and checking the buffer quality, you can set the frequency for the use. Uh, then there is a question for Sachin Bodke sir. So thank you sir for raising the question. Which pH electrode is best suitable for testing distilled water samples? So for the distilled water samples, basically the conductivity of those distilled water samples is very low, almost near to the zero. So in case of lower conductivity samples, the use of triple ceramic junctions and the electrode which is specifically designed for the low conductivity samples will be ideal for use. So I will suggest the triple ceramic junction with low conductivity sample suitable pH electrode for the distilled water pH measurement. Uh, Another question from Shyam Kumar sir. Thank you sir for the question. How can I understood whether my pH electrode is working properly? So you can perform the calibration for the pH. You can perform the calibration for your pH electrode. So depending upon the slope value of that calibration, you can find out the pH electrode is working properly or not. Uh, Thank you, Devin Kumar Gurjar sir. We will share the presentation after completion of webinar. Shyam Kumar sir, what is the storage? Thank you sir for the question. What is the storage solution? So basically, storage solution come just like the buffer solutions. There is a specific storage solution to store the electrodes which maintain the um, uh, hydrate layer of that pH electrode at the same level, so it does not um, the composition for the storage solution is not directly exposed, but it helps us to store the electrodes in the proper condition to get the good results for the next analysis. And Madam, thank you for your question. Could you please explain the slide classification on the basis of number of ceramic junction and which type of electrode is suitable for paint industry? So basically, ceramic junction, number of ceramic junctions affect the rate of flow of electrolyte from inside of electrode to the sample. So if your sample requires the higher electrolyte flow, then the triple ceramic junction will be more preferred. So even in case of paint industry, the triple ceramic junction electrodes will be more suitable. Pragyan sir, thank you for your question. Can you just describe your question in either mail or after completion of webinar, as it seems some incomplete question? I don't understand which concept you want to explain. Thank you, KVS Sharma sir, for your question. So pH range is 0 to 14, whereas the instruments are capable to check up to 18, and in the negative range also. Please elaborate how. So this is also the good question because some of the meters have the pH range starting from -2 up to 20. Even the basic pH range starts from 0 to 14. So the pH value is generally derived from the millivolt values. So depending upon the millivolt value, it gets converted into the pH value. So the meter is able to read the values which corresponds to the -2 pH value and which corresponds to the +20 pH value. So that's why the pH range is given like -2 to 20. Even there are rare samples which uh, has the pH value below 0 and above 14. The pH range explained as -2 to 20 or some higher values, just for the millivolt conversion or the capability of that meter for the millivolt readability. So there are a lot of questions in the Q&A. It will be difficult to answer one by one. So for the remaining questions, you can directly put your questions on that mail ID mentioned in the last slide, or you can contact directly on that contact number. I will hand over to Nanika.
Thank you, Omkar, for the detailed presentation. It was really nice, and I hope all of the queries are answered. For the remaining queries, please mail us your questions to marketing@hanainst.in or titrators-ns@hanainst.in. So we will be happy to answer all your queries related to pH and other instruments. Thank you all for joining today, and uh, please share your feedback after this webinar. And you will be getting the recording of the webinar on email ID after this webinar is over. So thank you all for joining today and for all your queries and participation. It was really, really great to see everyone's interest on this topic. Thank you, everyone. Thank you all. We will be ending this webinar for now, and the remaining queries we will answer directly on your email ID. Thank you.